Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the TEAS. We have been solving math problems out of this book here, the study manuals for the TEAS. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 61. Please turn to it. Page number 61, and today is our lesson number 8. Let's see what we can do there. There are 4 practice problems on that page, which have to do with multiplying and dividing by decimals. Number 1. So here are the practice questions. Number 1. It says compute the product of 6.3 and 7.6. Now, as we have been talking about for the last couple of days, when you're dealing with multiplying and dividing, particularly when we are multiplying numbers involving decimal, the smart thing to do is to ignore the decimal point completely, altogether, and just do the multiplication as you would do two ordinary numbers. Instead of 6.3, look at it as 63. Instead of 7.6, look at it as 76. And just multiply them out, and we'll worry about the decimal at the end. So let's do it. 6 3s are 8. Carry 1. 6 6 are 36. Plus 1 is 37. So that part is done. Now let's multiply by 7. 7 3s are 21. 1. Carry 2. 7 6s are 42. 42 plus 2 is 44. 44. You see? 7 6 are 7 6s are 44. That's what I was trying to say here. So that's it. We're done. 8, 8, 7, and 4. That's all. And now we stick our decimal point wherever they belong. So here it was 6.3, so it goes here. And then we have 7.6 that goes here. So we have one decimal place here, we have one decimal place here, which means whatever our answer is, we have to move the decimal places by 2 spots. 1, 2, it ends up here. So the final answer is 47.88. 47.88. Which should not be too much of a surprise to us, because what we are looking at here, if you want to approximate very quickly, if you want to approximate, what we're dealing with here is 6 times 7.5. That is an approximation. 6 times 7.6, you see, is 7.5, and this is 6.3. So, and this is 6.6. So we're actually underestimating it. Instead of 6.6, we're taking, instead of 7.6, we're taking 7.5. Instead of 6.3, we're just taking 6. So we're actually underestimating. So our answer is going to be slightly less than the correct answer. Let's see what we find here. 7 6 are 42, and then half of 6 is 3. So you see, we are getting 45. The correct answer turns out to be 48. But that's the quick way of approximating if you have to approximate. Approximating is fine, estimating is fine, as long as you're fully cognizant throughout the entire process of whether you're underestimating or overestimating. Many times I find out that the students can estimate, but they have no clue at the end whether the answer they arrived at is an underestimation or an overestimation. Of course, this is an underestimation for 2 reasons. Instead of 6.3, we have 6. Instead of 7.6, we have 7.5. Let's do the next one. Number 2. Number 2 says divide divide 3 into, divide 0.05 into 0.71. Now what does it mean to divide something into? For example, if someone says divide 3 into if someone tells us to divide 3 into 66, what does it mean in English language? What are they asking here? When someone says divide 3 into 66, what they're asking here is how many 3's are there in 66? That's what they're asking. And how do we find out how many 3's are in 66? Well, we take 66 and we divide by 3 and we get 22. That's the exact same thing we're going to have to do it here. When they say divide 0.05 into this amount, we take that amount 0.71 and divide that by 0.05. Let's do that, shall we? So we take 0.05, 0.01 rather, 0.71 rather, and we divide it by 0.05. And as we have learned in the last couple of days, don't do the division problem when you have to divide one decimal by another decimal. Don't do the problems in the way that is shown in the book, which is very academic way, very nerdy way, very confusing way, very prone to making mistakes. Convert this thing into fraction and just multiply the two fractions as we have done yesterday, as we did day before yesterday. So 0.71 can be written as 71 over 100 divided by 0.05 can be written as 5 over 100. And when do we do when we have one fraction and we have to divide one fraction by the other fraction? Well, it's right here. When we have to divide, it should say, when one fraction is being divided by another fraction, we take the first fraction and we multiply it by the reciprocal of the second fraction. So we take the reciprocal of this thing, 100 over 5, there we go. That's it, we're done. When one fraction is being divided by another fraction, we take the first fraction and we multiply it by the reciprocal of the second fraction. 5 over 100 becomes 100 over 5. Now we divide top and bottom by 100, we can get rid of this 100 very easily, and what we end up here is 71 over 5. And of course 71 over 5 can be written as 70 over 5 plus 1 over 5. How many 5's in a 70? Let's find out, shall we? How do we divide 70 into 5? Well, we ask ourselves, how many 5's in a 7? 7 has only one 5. The remaining 2 goes and joins a 0 and becomes 20. How many 5's in a 20? 20 has 4 5's. So it seems like 14 5's are 70. So this part becomes 14. 14 plus 1 over 5, which is simply 14 and 1/5. The very last thing we have to figure out is how to write down this 1/5 as a decimal. How to write 1/5 as a decimal. So we're going to pick up from here. I shouldn't have actually erased it right away. We're going to pick up from there. How to write this 1/5 in decimal has to do with knowing your tenths and your fifths in terms of decimals and fractions, which is what we can do right now. Tenths and fifths. I don't think it needs apostrophes. So let's do it, shall we? So here's our 1/10, 2/10, 3/10, 4/10, 5/10, How much is 1/10 in terms of decimal? It's just 0.1 obviously. 2 over 10 is going to be 0.2. 3 over 10 of course is 0.3. 4 over 10 is 0.4. And finally 0.5. What we notice here is that this 2/10 here can be reduced. If we divide top and bottom by 2, we end up with 1 over 5. This is 1 over 5. Which tells us that 0.2 is actually 1/5 is equal to 0.2. Similarly, 4 over 10, if we reduce it, we end up with 2/5. You have to know your fifths by heart. 5/5, 5 divided by 10, of course, is just half. Which is why we get, I shouldn't have circled half, because we're not, right now we're talking about the fifths. And half, of course, is 0.5. What does it show? What does it equal to in percentages? These were the decimals. Let's do the percentage. That's just 10%. 1/5 is same as 0.2. If you're given in terms of 1/5, which is what we had a little while ago, 14 and 1/5 I believe it was, and then in that case the answer would have been 14.2. 1/5 is 20%. 3/10 of point is 0.3, which is 30%. 0.4, which is same as 2 over 5, 2/5, which is 40%, and finally 5 over 10, which is half, which is 50%. Let's carry on then. I need the room. Do we need this thing anymore? We quickly take a look and see if we... Obviously we can't leave it on the blackboard forever. We need the room. So here we go. Six-tenth, 7/10, 8/10, 9/10, and 10/10. Again, 6/10 can be written as, well, let's first worry about the decimal, which is 0.6, 0.7, 0.8, 0.9, and this is just 1. What does it equal in terms of percentages? Well, 0.6 is just 60%, 70%, 80%, 90%, and 100%. I know this is very basic, but you have to know this by heart. You can't depend on the calculator in the exam, obviously, as you know. So let's take a look at, essentially, the reason we are doing all this thing is not to learn our 10th. Everybody knows the 10th. It's the fifth that we want to learn. 1/5, 2/5, and there is your 3/5. 6 over 10 is your 3/5. And 3/5, as we can see, equals 60%, 0.6. There is your 7/10, and then finally the 4/5. 8 over 10 is same as 4/5, which equals 80%, 4.8. And finally the 5/5, which is going to be 1, obviously. That's it. What we're going to do tomorrow, so very carefully, what we're going to do tomorrow we will do the quarters, the eighths, and finally the thirds. And you should know these by heart. You should have these quantities on your fingertip without having to think about it, without having to stop, without having to pause, because all of those things take time. They make you nervous, and you're more likely to make a mistake if you have to stop and think about it. You should know 5 concepts. You should know your tenths, you should know your fifths, 1/5, 2/5, 3/5, 4/5, 5/5. You should know your fifths. You should know your quarters, your eighths, and thirds. The eighths, the quarters, and the thirds we'll do tomorrow. Okay? Bye now.